Hello all, welcome back with one other question from GATE 2021. The question says the number of degrees of freedom for the following reacting system is M plus CO2 is converted to MO plus CO. So first of all, let us try to understand what is this degree of freedom. So basically, degrees of freedom, which is denoted by F. Okay, it is nothing but the number of independent variables that are associated with my system. So typically for any metallurgical system, what might be the variables that come into your mind? It can be, temperature, it can be pressure, it can be composition of a particular element or phase present in the system, etc. So this is nothing but the degree of freedom. Okay, what is the system here? The system is nothing but my reaction. Okay, so M, let me write it over here, is reacting with CO2 gas to form MO, which is the oxide, and CO gas, right? So we need to calculate the degrees of freedom of this particular reaction or this particular system. So we have very well defined rule which is called as my Gibbs phase rule, okay, which can be used to calculate my number of degrees of freedom. So F is equal to C minus P plus 2. This is the very famous Gibbs phase rule. So what are these? So as I just mentioned, F is nothing but the degree of freedom. C is nothing but the number of components present in my system. Okay. So again, what is a component? Component is nothing but the chemically independent constituents, number of chemically independent constituents that you have in your system. Let's say if you have one component, we call it a unary system. If we have two components, let's say solid solution of copper nickel, okay, we have two components, copper and nickel. So there we say it is a binary system. So basically the number of components are two, we call it a binary system. If they are three, we call it a tertiary system. If the number of components are four, we call it a quaternary system. So these are well defined based on the number of components. Okay, what is P? P is nothing but the number of phases that are present in my system. Again, what is a phase? Phase is nothing but a chemically homogeneous, mechanically separable, and physically distinct part of your overall system. Let's say, what is an example of a phase? It can be a solid phase, liquid phase, gaseous phase, alpha iron phase, gamma iron phase. So all these are known as the phases, which are chemically homogeneous, mechanically separable, and distinct. Okay, they are physically distinct. Now let's try to apply this Gibbs phase rule to our system. Of course, here maybe I can write it in this way. Okay, equilibrium. Okay, now so for a given reaction, how you can calculate the number of components? So here we have one more, way to easily calculate, which can be C equal to N minus R. So what is N? N is nothing but the number of reacting species, I can say, or maybe the number of species involved in the reaction. Okay, whereas R is the number of reactions between them. Okay, so this is the most simplified way how to calculate the number of components for a reaction. So here you can see what is N. So we have four species: M, CO2, MO, and CO. Right? So that means C is equal to 3, and all these four, sorry, N is equal to 4 minus all these four are related via only one reaction, right? So 1. So the number of components here are 3. Okay, that means you need three independent, you need three independent constituents to actually define the compositions of the system. Okay, what are those? M, carbon, and oxygen. Very simple, right? And what are the number of phases? P. It is also equal to 3. How? Because I just said, right? So solid, M solid and MO solid, even though both are solids, they are two different solids. That means they can easily be differentiated, right? So you have two solids and we have one gas, CO and CO2. You cannot actually separate them, correct? You cannot actually separate them, you cannot differentiate them. Therefore, these two gases together are taken to be only one phase. Whereas, because you can easily differentiate them, individual solid is taken to be one separate phase. So the overall phases are three. Okay, I hope you are getting the point. So now applying all these and putting into my Gibbs phase rule, F would be how much? 3 minus 3 plus 2. Therefore, the number of degrees of freedom associated with this reacting system is 2. So that's it for this question. I hope you understood the point. Thank you guys.